So having looked at the arithmetic progression and geometric progression, the basic concepts of these two types of sequences, we can now look at extended examples, or some few more examples on these two types of sequence. So we have a question here which says the first three terms of a geometric progression are 6 plus n, 10 plus n, and 15 plus n. Find the value of n, find the common ratio, and find the sum of the first 6 terms of this sequence. So that we are told this is a GP with 3 terms given. The first term is 6 plus n, the second term is 10 plus n, and the third term is 15 plus n. So we've only been given the first 3 terms. We don't know the 4th term, the 5th term, and so on and so forth. All right. So since we know this is a geometric progression GP, because this is a GP, it means there is a common ratio, meaning that when we divide consecutive terms, we get the same quotient value, a common ratio R, which means when we divide, for example, the third term by the second term, the answer we'll get is the same as the value for dividing the second term by the first term. So since these terms have all been given in algebraic form, it means we can express that understanding in equation form, where we say our common ratio is found by dividing 15 plus n, which is the third term. We divide it by the second term, and we are saying the result should be the same as dividing the second term. The second term we divide it by the first term, so the result will be the same, meaning this should give us the common ratio R. Okay, 15 plus n over 10 plus n is equal to R, just like 10 plus n over 6 plus n, it's also R because it's a common ratio. So because we have created an equation here involving fractions, it means we can cross multiply and get our value of n. So cross multiplying this, will have 15 plus n as a factor, multiplying 6 plus n, which is equal to 10 plus n squared, or 10 plus n, multiplying also 10 plus n. So when we simplify this by expanding these two factors that are multiplying, we'll have 15 multiplying 6 plus n, then n multiplying 6 plus n. This should give us 90 plus 21n plus n squared. The other side of the equation, expanding 10 plus n, multiplying 10 plus n, this should give us 100 plus 20n plus n squared. So when we collect the like terms here, we get the like terms. N squared will subtract n squared, meaning it will become 0. Then we'll remain with grouping the n's. We have 21n and 20n. These can come one side, and the number 90 and 100 also, we group them on one side of the equation. So we have 21n minus 20n, that will equal 100 minus 90. So 21n minus 20n, that will give us n is equal to 100 minus 90 is 10. So that is the value of n, meaning that our terms are 6 plus n, which is 6 plus 10, which means the first term of this GP is 16. The second term is 10 plus n, meaning 10 plus 10, which is 20. The third term is 15 plus n, which means 15 plus 10, which is 25, and so on and so forth. All right, so that is the value of n. That is the value of n. So to get the common ratio, we have said that we need to divide consecutive terms. So for example, if we get 20 divided by 16, or 25 divided by 20, whichever of these two that you get, you'll be able to find 1 1/4 or 1.25. That is the common ratio. And finally, we get the sum of the first 6 terms. The sum of the first 6 terms. So we say sum of the first 6 terms. Now, since our common ratio r is greater than 1, it means we'll use the expression where we have this is our a. Our first term is 16, which is a. Then r power n, which means 1.25 power n. N is 6, number of terms, and then minus 1. This over r common ratio, which is 1.25 minus 1. All right, so simplifying this, we have 16 times 1.25 to the power 6. This gives us about 3.8. So we have 3.8 minus 1, which is 2.8. Then over 1.25 minus 1, which gives us 0.25. So there it means we multiply 16 times 2.8, then we divide by 0.25 to give us 179. 179.2, or simply 179 to 3 significant figures, correct, to 3 significant figures. So that is the sum of the first 6 terms of that GP. we can solve this question, this other example, in a similar way as we have worked out this question. We can solve this other one where it says the first three terms of a geometric progression, x plus 1, x minus 3, and x minus 1. We find the value of x, we find the first term, we find the sum to infinity. So here we have another geometric progression which has it has the first term is x plus 1, second term is x minus 3, and x minus 1. So x plus 1, second term is x minus 3, third term is x minus 1, fourth term we don't have it, fifth term we don't have it, and so on. So we want to find the value of x. So since this is a geometric progression, it means we get an expression for r. We know we can get r by dividing consecutive terms. So the consecutive terms, when we divide x minus r, the third term, by the second term, sorry, this is supposed to be x minus 1. When we divide x minus 1 by x minus 3, which is the second term, we'll get the common ratio r, which is also the same result if we were to divide x minus 3, the second term, by the first term, x plus 1. So that will give us the same result, common ratio r. So we need to multiply, we cross multiply these two equations, we cross multiply these two fractions, we cross multiply the two fractions across the equal sign. So have x minus 1 multiplying x plus 1. This is equal to x minus 3 squared, which is x minus 3 multiplying x minus 3. So expanding this, x minus 1 times x plus 1, this looks like factors of difference over 2 square, factors of difference of two squares, remember difference of two squares. So this when expanded, it simplifies to x squared minus 1 squared, which is the same as x squared minus 1, as difference of two squares. Then the other side we have x squared. When we expand here, we have x squared minus 6x plus 9. So solving this equation by grouping like terms together, the x squared will cancel. We'll have 6x is equal to 9 plus 1, which means 6x is equal to 10, or x is equal to 10 over 6. That is the value of x. 10 over 6, which can be written as 1.7. So we have that as the value of x. Now, the second part of the question says we find the first term, which means the first term was given as x plus 1. So it means we have 1.7, which is x, then plus 1. So this will give us 2.7 as our first term. Then the sum to infinity. So the sum to infinity, we get the sum to infinity by getting an expression for r. So we know that r is the common ratio. So because we know our x is 1.7, we know when we have first term is here 2.7. 2.7 is the first term. So the second term, which is x minus 3, would mean 1.7 minus 3, which will give us negative 1.3. Negative 1.3. So to get our common ratio, we need to divide negative 1.3, which is the second term, divide by the first term. The first term is 2.7. The first term is 2.7. Which will give us 0.5, negative 0.5. Give us negative 0.5. So the sum to infinity is given simply as a over 1 minus r, where we are taking r, which is less than 1, meaning we are using r without effect of its sign. So which means our first term a is 2.7 over 1 minus 0.5 minus negative 0.5, that is our r, which means our sum to infinity is 2.7. This is 1 plus 0.5, which is 1.5. So 2.7 divided by 1.5 is 1.8. So our sum to infinity is 1.8.